Hello everyone, welcome to Yourpedia Education. Today we are going to discuss the past paper of BDL. Right, in the BDL exam there are hundred of technical questions which we are going to discuss here. It is very helpful for the students which are going to prepare for BDL as well as the BEL. So it is very helpful for both of you if you are going for BDL or either you are going for the BEL exam. So you can see here the first question is, which of the following transistor amplifier configuration has the highest power gain? See, basically if I am talking about the power gain is the highest for the common emitter configuration. So what will be the answer? The answer will be A. Right, you can read here, highest voltage gain, highest current gain you can achieve in common emitter configuration. So you will got the highest power gain in your common emitter configuration. The autocorrelation function of a white noise is an, see basically if I am talking about the white noise has the power spectral density which is constant throughout the frequencies. Right, this is the power spectral density of a white noise. If you remember, what is the power spectral density of a white noise? That is constant for throughout the frequency, whose value is what? N naught by 2. So if you take its inverse Fourier transform, that will be converted into autocorrelation function. So Rx of tau, what is the Fourier transform of a constant value? That inverse Fourier, sorry, not Fourier, inverse Fourier transform of a constant value, that is impulse function delta t. So what will be the answer? N naught by 2 delta t. So it means the autocorrelation function of a white noise is an impulse function. So what will be the answer? Answer will be B. Right. Next is an intrinsic semiconductor. Inside the intrinsic semiconductor, the electrons and holes both are available, right, inside the intrinsic semiconductor. When you have extrinsic semiconductor, then you have either n type or p type. N type will have majority charge carrier as electron, p type has majority charge carrier as holes, right? That is the thing. So basically inside the intrinsic semiconductor, both electrons and holes are available, and current will flow due to hole and electron both. So what will be the answer? Answer will be D here. Next question. Right, in the 555 timer ICs, the series connection of 3 resistors set reference voltage, right, to the 2 comparator at what? See basically if you are seeing the 555 timer IC, the upper comparator reference voltage is 2 by 3 VCC and the lower comparator reference voltage is 1 by 3 VCC. So answer will be A. Right. So whenever he is asking about this one, so you can directly answer this one. There is several formula, we are not going to into that much because it is directly asked this question. Find the Jacobian of the transform of a polar coordinate. So you have to convert that polar coordinate and you have to find its Jacobian. So Jacobian is what? This one. This is the Jacobian. So individually if you take the derivative of x with respect to x, derivative of x with respect to theta, so Jacobian become derivative with respect to r is cos theta, right. Next is derivative with respect to theta, that is going to be r. The derivative of cos theta is sin theta. Then again the derivative of y, this is y, not x, this is y, r theta. So when you take the derivative of with respect to x, that is sin theta, and it is plus r cos theta. So this is the Jacobian matrix for this transformation, right. This is the Jacobian matrix for this one. So if you find the determinant of this matrix, so if you take the determinant of this matrix, the determinant is multiplication of this, that is r cos square theta minus plus r square r sin square theta. So when you take r out, that is become 1. So what will be the determinant of the Jacobian? So he is asking for the determinant of the Jacobian, right. So determinant of the Jacobian is C. Which of the following is the modified form of JK flip-flop by obtaining the connecting the input J and K together. See, whenever we are talking about the JK flip-flop, this is your JK flip-flop. We are providing the clock here, and if you connect both of them as a single input, let us take at, that is become T flip-flop, right? Because whenever you put 0 0 here, 0 0 here, it will hold the same state. So whenever your T, if you remember the T flip-flop and next state Qn plus 1, if your T is 0, T is 0, then both of the J and K will have 0 0. If J and K both are 0 0, it means in JK flip-flop it will hold the previous state, so it is become Qn. And if it is 1, if you remember both are 1 1, J and K 1 1, then it will be complemented the previous state Qn bar. So that is the truth table of what? That is the truth table of T flip-flop. So basically whenever you connect the the J and K together, right, combine two together and provide as an input, single input, that flip-flop will work like a toggle flip-flop. So answer will be a toggle flip-flop. Right, next, compute the signal power this with period 0.5. See what is happening here, you have a signal and you have to find its power. See, basically one sinusoidal have its power is what? Amplitude square divided by 2. Next sinusoidal will have power 4 square divided by 2, 6 square divided by 2, 2 square divided by 2. So how much is total power? 4 divided by 2, 2, 16 divided by 2, 8, 36 divided by 2, 18, plus that will be 2. So 2 to 4, 12, 30, 20, that is, sorry, 2 to 10, 10, 10 or 18, 20, 10 or 20, 30. So that will be 30 volt. Answer will be B when you add up these powers. So whenever you have a sinusoidal and you are taking the power, so take the individual power of each sinusoidal and add them. That is the way how you can find the power of a sinusoidal combination. See, if he is asking the programmable interval timer 8253 has how many mode of operation? So there are 6 mode of operation: mode 0, mode 1, mode 2, mode 3, mode 4 and mode 5. See, basically these mode of operation are interrupt on terminal count, second one is programmable, one on stop, one short, and rate generation, square wave generator, software triggering stop and hardware triggering stop. So these are the mode of operation. So there are 6 different mode of operation inside the programmable interval timer 8253. Next is electrical line of force always start from, see, if I am talking about electric line of forces, see, electric line of forces so always start, this is your plus, this is your minus, so they will start from the positive charge and they will terminate from the negative charge. So basically whenever you have electric line of forces, the positive charge will work like a source and the negative charge will work like a sink. So the electric lines of forces are started from the positive charge and they will terminate at the negative charge. So what will be the answer? Answer will be B, the positive charge and ends at the negative charge. That will be the answer for this question. Next is the optimum filter is called as match filter when its input noise is, see, basically whenever we are discussing about this optimum filter, the optimum filter is basically match filter. Why it is called as match filter? It is basically work for the input noise, that is white noise. It is only work for the white noise, because in the communication system when we studied these things, we are assumed that the input noise is AWGN, additive white Gaussian noise. So that's why we can say it is only work for white noise, right? Find the resolution of a 10-bit DA, digital to analog converter, having full scale output voltage is 10 volt. So full scale output voltage is 10 volt. So 10 volt divided by, that is 2 raised to power n. Remember, this is not 2n, 2 raised to power n, right? 2 to the power n. n is the number of bits, so 10 bits to 2 raised to power 10, so it's going to be 10 divided by 2 raised to power 10 is 1024. So when you divide the 10, it is almost 0.09, or you can say it is almost 0.0900, right? 00977. You can see it cannot be 10, it cannot be 9 point, it can't be like this. This is the answer, C answer. It is around this, it is in volt. If you convert it into millivolt, that is become 9.77. so how you can make an idea? You can just divide that thing, because it is a 10. So when you divide, one is going because if you put the decimal, there should be 20 before the non-zero quantity here. So we will got that there will be answer is 9.77. so how you can get the idea without the calculator? The process of electron emission by applying a strong electric field at the surface of the metal, right, is known as field emission. That is not photoelectric effect, because we are emitting the electron by applying a strong electric field. So that's why it is called as field emission. If you apply the light on the surface, and due to that light, if electrons are eliminated from the surface, that is called as photoelectric effect, right? That is a different thing here. So it is called as photo emission, right? See, secondary emission is talking about the emission of electron caused by the impact of high energy particles, that is called secondary emission. Photoelectric emission of electron when light is sufficient in energy strike on the surface of the metal, right? Photovoltaic effect, generation of voltage or electric current in the material upon exposure to the light, and typically used in solar cells. So that is the different thing here, right? Next is to construct an electric circuit, the board used in a radio receiver. See, basically all the electronic circuits are made up of on what? That is printed circuit board, that is used as a PCB. So PCB are used to make any electronic circuit this day, right? ILS board, breadboard, lungs board, these are not used there. Only the printed circuit board is used here, right? Next is find the RMS value of a full wave rectifier AC. RMS value of a half wave rectifier AC signal is 100 volt. See, basically what is the relation between the RMS value of a full wave rectifier and RMS value of a half wave rectifier? This is the relation. So you have to multiply that by root 2. So it is under root 2 times 100, that is 141.4. So what will be the answer? Answer will be B. A RC coupled amplifier, the drop in the gain at low frequency is due to, see, in RC coupled amplifier at low frequency your gain is decay due to coupling capacitors. At high frequency your gain will decay due to internal capacitance, right? So what will happen? It is due to capacitive reactance at low frequencies, right? Next is in a N-type semiconductor at a temperature T, the Fermi level. See, whenever you increase the temperature, the Fermi level will move to the mid of the, see, again the same thing which I already discussed in one video, that is EDC video, which is already available on the portal. You can check it here. Whenever you increase the temperature, see, you have a, let us take, you have a N-type semiconductor, right? In N-type semiconductor, currently your Fermi level is lying near the conduction band. So what is happening here? The holes are very less, right? Holes are very less, electrons are very high, right? Now I am increasing the temperature. Now as increase the temperature, hole concentration will increase, but electron concentration is not increasing that much, because it is a majority charge carrier. When hole concentration will increase, that means this Fermi level will shift it down, right? So it is going near to the center of the one, right? Moving towards the middle of the forbidden gap, that is B answer here. Next is, what is the expression of Poynting vector of an isotropic point source at a distance of r? See, basically whenever you have an isotropic radiator radiates in all the directions. So if it is all radiating all the direction, so it means it will radiate total power through the surface area of a sphere, right? If I assume a point charge here and it will radiate in all the directions. So if you assume a surface which is going from this one, right, which is going from this at a r distance, you can say, right, which cover this point charge at the center, so all the power will emit from that surface. It is uniformly emitted. So what we can say, the Poynting vector is defined as the average power density. So average power density per unit area is what? Total power radiated by that one divided by 4 pi r square, the area of that sphere, because the all power is radiated from that spherical area, right? So that is 4 pi r square. P divided P is the total power. So what we can say, that is the average Poynting vector. If a live conductor of public supply touch earth metal, then if your live wire is conducted, so the total current will pass through the earth, right? Because the current will follow the lower resistance path, the current will flow to the earth. Answer will be A. What is the value of this limit? Limit x tends to 0, x sine 1 upon x. See, basically this has become limit x tends to 0. So if you put x tends to 0, x sine 1 upon x. See, basically when you put 0, to 0 multiply by sine infinity, right? Sine infinity, because if you know that sine is a function which take the value between, this is cos, this is sine. Sine is a function which take the value between -1 to 1 if you take any value of t. So if I take the infinity, but still its value is lying between -1 to 1. So what is this? This value is finite. If any finite value is multiplied by 0, that is become 0. So what will be the answer here? That is 0. This limit value is 0 here. So this is x here, this should be 0. The answer will be 0 here. Next is, what happens when an operating frequency of an operational amplifier is increased? See, whenever you increase the operating frequency, what do you know about the any amplifier? About any amplifier, the gain into bandwidth product always remain constant. So basically, if you increase the bandwidth, the gain will be decreased. So what is happening? No option is correct. The phase shift of the amplifier is decreased, gain will decrease. So answer will be C here. Remember that thing, if you have any amplifier, for any amplifier, gain into bandwidth product is always constant, right? How many comparator are used in a 4-bit flash type analog to digital converter? So if you have analog to flash type analog to digital converter, there are number of comparators are required 2 raised to power n minus 1. So if we have 4, that it means we require the 15 comparator here. That is the directly formula based question from A to D converters. The overall transfer function of 2 blocks in the parallel. Whenever you connect the 2 blocks in the parallel, this is Z1, this is your Z2. You connect 2 blocks in the parallel, then overall transfer function, when you combine them, that is become G1 plus G2. Whenever you have 2 blocks in parallel, then the overall transfer function will be the addition. Whenever you have 2 blocks in the series like this, the overall transfer function will be G1 into G2, the multiplication of these two. So that is important. Whenever you have in parallel combination, then they will be added. Whenever you have the series combination, they will be multiplied with each other. So what will be the answer? Answer will be sum of indivisible gains. The advantage of DC system over AC system. So these all are the advantage of DC system. What is no charging required? What are the advantage of DC system over AC system? No charging current, improve line regulation, no skin effect, because in AC circuit there is a skin effect. So all are the answer, means all are the options are correct. If I am talking about the DC system, there is no charging current. AC transmission capacitive effect cause the charging current, especially in long distance high voltage transmission, and DC transmission eliminate the charging current, leading at better efficiency, improve the line regulation, right? And other one, the skin effect is not also available inside the DC. Which semiconductor device is used in barcode reader? See, basically if you are seeing that whenever you have a barcode, you just flash a light, there will be a laser light, so that laser will read that thing. So which light will use? That is laser diode we are using there. In if the length of a V antenna is increased, then its directive gain is also increased. U and V are the conjugate harmonic function. If, see, if they are a harmonic function, right, if they are a harmonic function, they should be analytic. So here is the proof, you can check it, right? If the given function is U and V are harmonic, then they are also analytic functions, right? Remember that thing. PLL can be used to demodulate. See, PLL, I already discussed that thing. The PLL is used to demodulation of FM signals, right? It is used in the demodulation of FM signal. Find the general solution of differential equation. We have a differential equation, dy by dx is equals to y by x. So if you take dy over y is equals to dx over x and you integrate both the sides, so ln y is equals to what? Ln x plus c, and you take this one into this side, so ln y by x is equals to what? C, and y is equals to x times e raised to the power c. You can take it another constant, so y is equals to kx. So what is the answer? Y is equals to kx. That is, the answer is B. A communication satellite is the repeater between. See, if you see that video, I already uploaded the video about the satellite communication. I think it is available on panel, you can check it there. See, that is this is the transmitter here, this is the receiver here, and whenever we transmit a signal from transmitter to the receiver, this is your satellite here. So satellite will work like a repeaters, right? It will take the signal from one or many station and it will transmit the same signal to one or many station. So many transmitting stations and many receiving station. So it will take the signal from many receiving sending stations, you can say transmitting station, and it will send that signal to many receiving station. So satellite will work like a repeater between them, right? See, the maximum temperature permitted for a class A insulation is, whenever we are going about the insulation, so for class A insulation, that is 105 degrees. So it is you can say it is fixed. So every class head is class A insulation have that much maximum temperature, class B has that much, and every insulation has its own use. Like class A insulation is used in the material which are included, that paper, cotton, silicone, synthetic, Rennis bender, and it is mostly used in power electronics machines, transformer and appliances. It is used in there. So that's why it is important. Class A, you have to understand that it will maximally work on 105 degrees centigrade. See, hexadecimal number 64 BD is equivalent to the decimal number. So first what you can do, there are two ways to do that thing, so we have to convert it into decimal. So first way, you can directly multiply that thing, right, like this. The D will be multiplied by 16 to the power 0, 16 1, 16 2, 16 3, and then you can convert them and add them together like this. So you will got the decimal number, that is 25789. So that is the decimal number. How you can get that one? You can see this complete complete solution. The input impedance of a lossless transmission line is 100 ohm when transmitted in a short circuit and 60 ohm when transmitted as a open circuit. See, always remember, whenever you have a short circuited and open circuited line, then your characteristic impedance is under root of open circuited impedance and short circuited impedance. The under root of open circuited and short circuited. So just plug in the values. So it is 100 into 64, which is going to be 6400. When you take the square root of this one, that is going to be 80. So answer will be 80 here, right? Next question. Which of the following term define the filter used in communication engineering? See, basically in communication engineering we are just use the frequency selective filters, right? Either you can use low pass, high pass, band pass, or band stop. These are the frequency selective filters, right? Amplitude damping circuit, no. Frequency damping circuit, no. Amplitude selective circuit, no. We are using a frequency selective circuit, that is called as filter, right? Either it is low pass, high pass, band stop, either any type of filter we are using in communication. That is the answer here. Which amongst the following plays a crucial role in determining the state of a dynamic system? So whenever we are finding the state of a dynamic system, the state of a dynamic system is only defined by the state variables, right? So answer will be state variables. In control system you already studied this thing. And the period of a function, see, whenever we are finding the period, this is cos omega t minus t naught. So basically when you compare these two, omega is going to be pi by 4 and 2 pi over t is equals to pi by 4. So pi to pi cancel out, time period is going to be 8. So answer will be C. The single bit indicator the single bit indicator that may be set or cleared to show the result of a logical or arithmetical operation is that. See, basically it is a single bit, right? The single bit which is showing that the status of your result, that is a flags, right? Single bit indicator that is set or cleared to show the result of a logical or arithmetical operation, that is flag. There are several types of flag, that zero flag. Accumulator is the things where you can store the results. Stack pointer is different, data pointer is different. So basically the flag which is either it will be clear or set whenever you do any logical or arithmetical operation. So answer will be A. There are these type of flags: zero flag, carry flag, sign flag, overflow flag, and other one is parity flag, right? So they will be changed accordingly whenever you do one arithmetic operation. USART chip provided. See, if I talk about USART, USART chips, that will provide you full duplex operation in the communication, right? Which of the following antenna is the standard reference antenna for the directiveness? If I am talking about the reference antenna, standard reference antenna, basically the standard reference antenna is what? That is isotropic antenna, right? Which radiates in all the direction with same intensity, you can say. So what will be the answer? That answer is isotropic antenna. That is a standard reference antenna which we are using. The transfer function of a system is the Laplace transform of its under all the initial condition is 0. See, basically the Laplace transform transfer function and the impulse response. H of S is what? Laplace transform of H of t. H of t is what? That is impulse response. So if I am talking about the relationship between transfer function and impulse response, so the transfer function is the Laplace transform of your impulse response. So answer will be C here. The forward bias Vi characteristic curve of a rising linear. Okay. In forward biasing Vi characteristic, the curve rise linearly after barrier voltage. right? Barrier voltage. See, basically your curve will be linearly rising like this after the barrier voltage will overcome. Whenever your barrier voltage is overcome, due to this barrier voltage, no charge carrier is crossing the junction. Whenever your barrier voltage is overcome by the external voltage, then there will be a current will flow. So what will be the answer? In forward bias VI characteristic, the curve rise linearly after barrier voltage is overcome, right? When you overcome the barrier voltage, then there will be a linearly increase in your current. So the answer will be A here, right? Determine the causality and time invariance of the system. See, basically if I am talking about this system can you see here, if I put t equals to 0 here, if I put t equals to 0, so y of 0 will depend of x of minus 2 and x of 2. This x of minus 2 is the past value, but this x of minus 2 is the past value, x of 2 is the future value. So basically for a causal system, your output will only depends on present and past value, not future value. So here what we are seeing that this system output is depend on the future value, that's why it is a non-causal, right? For time invariance, if I put a delay in the input, if you put x of t minus t naught, right, we will got what? y1 of t, let us take, that is going to be x of t minus t naught minus 2 and x of 2 minus t naught, and if you take from here and you put t minus t naught in y, right, so that is also x of t minus t naught minus 2, the same delay, plus x of 2 minus t naught. So both the values are same. What we can say, see, if I put the delay in the input, the same delay will be reflected in the output. So that's why it is linearly, not linear, it is a time invariant system. So what we can say, it is a non-causal time invariant system. Understood? Right. Here in details I already wave propagation occur without attenuation as in free space. Wave propagation occur without attenuation in free space for sigma equals to 0 in case of A and N. See, basically if I am talking about the EM wave is easily go through the dielectric medium. So we can say the dielectric medium is a perfect conductor for an EM wave, right? So if I am talking about attenuation in free space sigma is 0, so it means it is a dielectric medium or perfect dielectric medium. So what will be the answer? The perfect dielectric. The wave propagation occur without an attenuation as in free space because that is work like a perfect dielectric material, right? That is the reason. Silicon junction state to conduct when the voltage across the junction reaches 0.7. It's an easy question, right? This is directly. The frequency modulation. In frequency modulation, noise will decrease as you increase the delta F, frequency deviation. So frequency modulation, noise is decreased by increasing the deviation, frequency deviation. That is the relation here, right? Next is, what is the modulation index? Vmax, Vmean is given to you. The modulation index formula is this: m is equals to Vmax minus Vmean divided by Vmax plus Vmean. So you can just plug in the values and you will go, the value is 0.662. What is the vector location of an interrupt RST 6.5 in 8085? If I am talking about RST 6.5, so just multiply this 6.5 by 8, and when you multiply this by 8, it is going to be 4 plus is 48, that is 52, right? When you convert this 52, this is in decimal, this is the decimal vector location. When you convert this 62 into hexadecimal, that is become 30034H. So whenever he is asking about the vector location of any of the interrupt, just multiply that value by 0, just like RST 6.5, RST 5.5, the value by 8, then you will got the decimal value, convert that value into hexadecimal, you will got the location. So the location is 0034 hexadecimal number. Okay, is defined, which of the following is defined as the modulation technique which combine the phase and the amplitude, modulation, that is QAM. QAM is the combination of ASK and PSK, right, in which we have amplitude also vary and the phase will also vary. So that's why it is a combination of ASK and PSK. We can say there is a phase modulation as well as amplitude modulation, right? That is what the answer is, QAM, right? Quadrature amplitude modulation. Which of the following nodes in a signal flow graph has only outgoing branches? That is the input node. Input node having only the outgoing branches. The ability of a op-amp to provide a sufficient differential mode signal but reject the common mode signal is called as CMMR, common mode rejection ratio. The Hilbert transform is a system. If I am talking about the Hilbert transform is this. Can you see here? This is the formula for the Hilbert transformer. So if you are taking the Hilbert transform of xt, that will be integration from minus infinite to infinite. So you are integrating from minus infinite to infinite, you are adding all the past and the future values. That's why it is called as non-causal signal. Non-causal. Hilbert transformer is a non-causal system. Which of the following semiconductor material normally used to fabricate the infrared LED? See, if I am talking about the infrared LED, generally gallium arsenide is used. Here you can read the each one of them. Germanium is not used for LED fabrication. Silicon is also not used. Gallium is not compound semiconductor. Gallium arsenide is a compound semiconductor because gallium is not a semiconductor, right? Remember, because germanium and silicon are not used as a LED because they are indirect band gap semiconductor. LEDs, the material used for making LEDs, that is a direct band gap semiconductor, and that is gallium arsenide here. The characteristic impedance of a transmission line is known as natural impedance of your line, and the formula for that one is Z0 is equals to under root of L by C. If three resistances are connected in series, the equivalent resistance, whenever you connect the three resistance are equivalent, that is R plus R plus R, that is 3 R's. Two discrete time system with impulse response H1T, that okay, H1T are connected in cascading, the overall impulse response, whenever you collect the cascading, then overall impulse response, see, I am talking about the transfer function. Transfer function is the multiplication, or gain is the multiplication. If it is impulse response and they are connected in cascading, the overall impulse response is the convolution, not multiplication, convolution of these two individual impulse responses. That is, answer is D here. Calculate the characteristic impedance of a quarter wave transformer where the load and the input impedance, see, always the characteristic impedance Z0 is equals to under root of input impedance, or you can say Z01 into ZL. So directly plug in the value, 4 into 16, 16 into 4 is 64, under root taking at the root, that will be 8. So answer is 8 here. Calculate the transmission rate of a TDM link with transmitting 200 frames per second, and each slot has 8 bits. So just multiply this 8 with the number of frames, because each frame required 8 bits. So 2 in 2000 into 8, that is 16 kbps. Answer will be C, 16 kbps is the answer. The Zener breakdown voltage with the temperature and avalanche breakdown voltage with the temperature. See, if I am talking about the Zener breakdown, Zener diode is heavily doped. If you increase the temperature, Zener breakdown voltage will decrease, but avalanche breakdown is for lightly doped, so that's why it will increase, right? Avalanche breakdown voltage will increase with increasing the temperature. For a 8-bit Johnson counter, find the number of unused state. In Johnson counter, if I am talking about the Johnson counter, used state are 2n. 2n are the used state, that is 16, not 162, that is 16. 16 are the used state, and unused state, total state that can be counted by a 8-bit counter, that is 256. So unused state are remaining 240. So remember, if you have a Johnson counter, the used state are 2n. If you have a ring counter, in that ring counter used state are n number of bits, right? And unused state are what? 2 raised to power n minus. In case of ring counter, that is 2 raised to power n minus n, and in case of Johnson counter, that will be 2 raised to power n minus 2n. Find the inverse Laplace transform of this one. So what you have to do, you have to find the inverse Laplace transform of this function. So make a perfect square. So in below, s plus 1 whole of square plus 3 square. So when you convert it like this, so it is become e raised to the power minus t, and then s, that is cos of 3t. So that will be the answer. Answer will be D here, right? That is detailed solution, you can check it. Monostable multivibrator is used. Use the timing element R is equals to this, C is equals to what is the time period. See, if I am talking about the time period, that is 0.69 RC. Just plug in the value R and C, and you will get the answer is 0.069 second, right? What are the solution of this differential equation? Okay, so you have to find the solution of this differential equation. So what we can do now, this is dy over dx, take it other side, that is minus under root of 1 minus x square. So what we can do, the dy is equals to dx upon under root of 1 minus x square, right? And now we are going to integrate it here, so that is minus also there. So y is equals to what? Minus sine inverse of x plus c. So now take minus is this one, take this one into this side, so it is become y plus sine inverse of x is equals to c. So that will be the answer. Which one is correct? That is c. Remember that thing, the integration of 1 upon 1 minus x square is sine inverse of x. The system having pole at origin, okay, the type of the system is defined as the poles at the origin. So if you have a type 2 system, it is type 2 system, it is having two poles at origin. So what will be the answer? Answer will be D here, right? So there will be two poles at the origin, then it is become type 2 system. 6 bulbs are connected in parallel across a 100-volt battery. Each bulb is rated as 75 volt. How much current is flowing through each block? See, basically from this one, what you can see here, it can absorb that power. Power is equals to what? V times I. So that is power is 75, and it is 110 times I. So from here you will quote the 75 divided by 110. So it's around 0.62, because it is the 75 is divided by 110. It is always less than 0.75. It is always less than 0.75. So which value is less than 0.75? That is 0.682. From the options you can eliminate that thing, right? The next question. The voltage control oscillator, that is VCO, right? The voltage control oscillator is a VCO, voltage control oscillator. Take input voltage and give output frequency, right? That is the main thing about this. The voltage control oscillator is do what thing? If you apply a voltage at the input, this convert that voltage into the frequency that is used to generate the FM signal. So we can generate the FM signal by using a voltage control oscillator. It is voltage to frequency converter, so we can say all the options are correct. The amplifier which amplify the specific frequency or narrow band of frequency, that is called as tuned amplifier. I already discussed that thing in your communication when we discussed about the amplifiers, right? Which of the following is a polarized capacitor? The polarized capacitor is titanium electrolyte capacitor, right? Tantalum. Find the characteristic equation of this one using Cayley-Hamilton theorem. See, first what we have to do, we have to find the determinant of A minus lambda I. When you solve this A minus lambda I determinant, you will got the equation like this, and by using the Cayley-Hamilton theorem, the lambda will be replaced by A, right? What is the Cayley-Hamilton theorem state? Cayley-Hamilton theorem states that every matrix should satisfy its every square matrix should satisfy its characteristic equation. So this will be its characteristic equation. When you put it equals to 0, lambda can be replaced by A. So what will we got the answer is B. So that is the answer here. The number of comparator circuit required to build a 3-bit simultaneous A to D converter. See, if you are making a simultaneous or flash type, that is the same thing, right? Simultaneous or flash type. So that is already one question is there. So that is 2 raised to power 3 minus 1. That is 7 comparator are required. What does SDL means? SDL is hardware descriptive language, right? That is the full form of SDL. VSDL VSDL is different from this SDL. Find the probability of number divide by 9 from 1 to 100 where the last digit is 9. See, first thing what we have to do, we have to find the number which are divisible by 9. That the number is 9. You can see here 9, 18, 27, 27, right, up to 100, right? That is 99. This is repeated here. Just don't follow this. And amongst these number, we have to find only those number whose last digit is 9. That is 99. And any other number, there is no other number which is ended by 9. So what we can say, 3 numbers last, okay, where at least one digit is 9. At least one digit, right? Here is 2 digit is 9, 1 digit is 9. Any other number which is having 9, there should be 2 or 3 numbers are there. Yeah, first number, that is 3. 3 numbers are there which is having 9 as any digit. So that will be 3 divided by 100. So what we can do, first we can write the total numbers from 0 to 100 which are divisible by 9. That is 9, 18, 27, 36, 45, 54, 63, 72, 81 and 90 and 99. Now find from these number, we have to find the number which is having at least one digit as a 9. So first number, this 90 and 99 having at least one digit as a 9. So 3 numbers, so 3 divided by total numbers are 100. So 3 divided by 100 is the probability. Transistors are sensitive to what? Transistors are sensitive to voltage, current and temperature. All of these things, they are sensitive, right? So answer is all of these things. Which is the mode of operation of photodiode? See, photovoltaic effect, avalanche diode, photoconductor, these are all can be used in photodiode. So what will be the answer? Answer will be the C, all the options right here. Okay. Thyristor. This is thyristor are the semiconductor device that are operated only in the switching mode, right? Because in the thyristor we are requiring external triggering to turn on that thyristor, and they are current operated device. Thyristor is a current operated device. The answer will be D. How many bits are present in a double word? See, if I'm talking about, first thing is byte are 8 bit, word are 16 bit, double word are 32 bits, quad word are 64 bit. So double word are of 32 bits here. Next is A, B, C, D, E, B are the pentagons. What is the resultant for this one? See, AB can be written as B minus A, like this. We can write it like this. If you add all of them, then what will be the result? All of them will be cancel out. So what we got? Minus 3A minus 3C, and when you combine that one, that is become 3 A minus C. So that will be the answer 3 A minus C. A minus C means sorry, C minus A means AC vector, 3 times AC vector, right? Okay, next. If data is present in a resistor and it is refers to using the particular register, then it is okay. If data is present in a resistor and we are referring to that particular register, that is a register addressing mode, because we are addressing the register, right? That is a register addressing mode, like we are moving move content of A to the register B, that is register addressing mode. What is the function of pin 8 in 555 timer? So these are the functions of the pin. Pin 1 is grounded pin, pin 2 is the start the timer, provide the output signal, pin 4 rest the timer. Like what is asking which pin? That is the pin number 8. The pin number 8 is the power supply, that is 4.5 to 15 volt. What is the term used for changing the op-amp offset voltage caused by variation in the power supply voltage? That is called as power supply rejection ratio, right? Next is matrix obtained by interchanging the row and column, that is transpose. If the curve fx is constant by the Newton-Raphson method, f dash x will be 0, right? It is not the question from the Newton-Raphson method, it is the question from the derivative. If you have a function as a constant function and you are taking the derivative of that function, that will always be 0. The initial response in a control system when the output take a certain time to reach the steady state, that is called as transient response. So if we are dealing with the response of the control system, there are two types of response of a control system. One is transient response. I am taking a unit step response like this. So the first part is this is a transient response, the second part is a steady state response. So basically initial response of the control system, right, to reach the steady state value, that is called as transient response. Right, what is the adjustable output voltage for a LM335 voltage regulator? LM335 voltage regulator is a negative voltage regulator, and which will provide you the output between minus 1.2 to minus 30.7, right? So remember that if you have LM337, you have to remember that it is a negative voltage regulator. It will provide you the negative voltage at the output. So from the options you can eliminate, only this one is a negative voltage here, right? A radiator which radiates uniformly in all direction, that is an isotropic radiator. Which of the following instruction upon execution modified the content of the accumulator in an 8085? See, CPI complement CPI means what? Compare the immediate data with the accumulator. So it is just a comparison of this immediate data with the content of the accumulator, or the accumulator with the accumulator. When you or the accumulator with the accumulator, the content will not change. CMPC that is not used in your 8085. EA and ICDH, that is and the immediate data available in this instruction, right? We have to AND that data and the result will be stored into the accumulator. So that instruction will modify the accumulator, right? That is the D. To get the admittance chart from the impedance chart, right? So what you can do, you have to see, you are getting the admittance chart from the Smith chart, you just reverse that. Reverse means you have to shift that by 180 degree. So 180 degree shift will convert the Smith chart right into the impedance chart into the admittance chart. New binary coded pattern, and this is the question from the previous year gate, right? BCP numbers are proposed in that you have to, basically the question is you have to convert this this is pantry means base 5 number to the decimal number. So just you have to convert. What you have to do, you have to make a group of 3s here, group of 3, then you have to convert it. That is going to be 4, that is going to be 2, that is going to be 3, that is going to be 1. 4, 2, 3, 1. So what we have to do, we have to convert that base 5 number into base 10 number, right? So what we can do, just convert that, make a group of 3 and then convert that into decimal. Which of the following statement is not correct? A PN junction diode symbol shows the arrow identify the direction of flow of current. That is correct. An ideal diode is a closed switch when it is forward bias, right? Ideal diode is an open switch when it is forward bias. In forward bias it is closed switch, not open switch. Open switch is it in with the reverse bias. Diode does not follow, it follow the Ohm's law, right? So answer will be C. The output of a logic gate is 1 when all its input are 0. That is XNOR gate, because whenever all the inputs are 1, the XNOR output will be 0, right? So there is an explanation for each option, you can check it here. A 3 dB beam width of an antenna is called as what? Half power beam width, right? At 3 dB means where your amplitude will decay to 1 by root 2 times and power will decay to 1 by 2 times. Which of the following is not possible in a circular waveguide? See, if I am talking about the circular waveguide, there is the mode TE10 is not possible in your circular waveguide. Which is the major component of computer system that does not process related to the arithmetic and logical operation? Does all the processing. See, basically if I am talking about inside your computer, there is a unit that is called a arithmetical logical unit, ALU, that is also responsible for all the arithmetical and logical operations. So answer will be ALU. Which of the following is the input operational mode of 8079 keyboard and display controller? That is strobed mode, strobed input you can say. What is the resultant modulation index of an AM signal which is having simultaneously modulation index? If you are talking about the total modulation index, the total modulation index is under root of mu1 square plus mu2 square. Just plug in the values here. Under root of 0.6 square plus under root of 0.4 square, that is become 0.36, 0.14 under root of 0.5. So it is 0.72 or 7, yeah, that is around 0.72, not 75. The MOS capacitor made up using p-type substrate in an accumulation mode, the dominating charge in the channel is due to the presence of holes, right? This is the accumulation mode. In the accumulation mode, if you have a p-type substrate, you have to provide the negative voltage at the gate. Then when you provide the negative voltage at the gate, they will attract the holes, or you can say they will attract the holes. So there will be holes are accumulated near the interface. So that's why the answer will be P in the accumulation mode. An acceptor in a semiconductor is, that is impurity which increase the holes concentration, right? The K-map is an abstract form of an organization of matrix in the square form, that is a Venn diagram, right? Venn diagram organization. When does the propagation occur for any mode of propagation in a rectangular waveguide? Whenever your input frequency is above the cutoff frequency of that particular mode, right? An ideal voltage amplifier should have ideal voltage. If I am talking about the ideal voltage amplifier, input impedance should be infinite and output impedance should be 0. So high input impedance, low output impedance, answer will be 0. 10 volt DC regulated power supply has a regulation of 0.005%. The voltage will be varying within the envelope of millivolts. So we have to convert that this 10 multiply by that voltage, right? So that is become this one. So the nominal value is lying between 2.5, right, like this. So that is 0.05. The variation is 0.05. That is a C answer, not B answer is here. 0.05 millivolt. If is asking, that is D answer, not C. D is the answer. Which of the following is the correct formula for the characteristic impedance of a transmission line? We already got 2-3 questions from this same formula in the same exam. The output, that is under root of short circuited and output. This should be under root here, right? I think it is missing here. Under root of open circuited voltage, open circuited impedance into short circuited impedance. So these are the questions from the BDL exam, right? So I think it is directly formula based. There is nothing, you have to only memorize the things here, right? And mostly around 5 to 6 are the conceptual question, rest questions are directly formula based questions. So if you are preparing for the BDL and BEL exam, you may join our ongoing courses where we are where hundreds of students are already joined that courses and they are preparing well, right? You may join that course and you will get the benefit of that thing in your BEL exam or BDL exam. That is really helpful for you, right? So hopefully this video will help you in your preparation. Thank you.